Okay, today we will start with the first lesson in our study for geometry this term. We will start with a topic that you will meet in your life more than one time. It's the circle. Okay, let's see these pictures. You have a figure like this. You have some circles inside each other. Okay, you have some circles also forming a shape. You have some hands forming a circle. Okay, so our topic today is the circle. So, what is the circle? What are the basic definitions or the basic concepts for the circle? And what are the theorems on the circle that what will we study in this term? First, we will start with some basic definitions of the circle. This is the circle. Okay, what is the circle? For the definition of the circle, you can see that the circle is any closed curve with all points at the same distance from the center. So, the circle, it's a figure or a curve having a center and having these points of the curve are equidistant from the center. Let's see, I have the center. I have a chord, circumference, diameter, pi, area, and a circle. This is the family of the circle. So, let's recognize its family and let's know all of these members of the family. I have the radius. We have forgot the radius. Now we will start with the first member of the circle. It's the center of the circle. What is the center of the circle? If I have a circle like this circle having a center is M. What is the center? It's a fixed point inside the circle, which is equidistant from its terminals. A circle is named by its center. So we can say that the name of this circle is M. Okay. When you see the playground, you have the center of the playground, and you will put the ball in the starting of the match at this center. So the playground having a circle and the circle having a center. I have the center of this circle is M, so we name the circle by its center. After that, the radius. I have the center of the circle. After that, the radius. What is the radius? We can see that the radius is the distance from the center of the circle to any point on the circle. So, the distance from any point on the circle to its center is called the radius. I have here the radius. It's a distance of the line segment drawn from the center to any point on that circle. After that, the radius is 1/2 the length of the diameter. What is the diameter, Mister? The symbol is lowercase r. So we can see that the symbol of the radius is r. After that, the diameter. What is the diameter? We can see that I have the circle is M, and I have a line drawn from A to B passing through the center. You can see that the line segment joining between 2 points on the circle passing through the center, it's the diameter. So the diameter of the circle is the line segment drawn or joining between 2 points on the circle, but you must have it passing through the center of the circle. After that, you have AB equals 2 radii. As we said in the radius, we said that the radius is equal to half the diameter. So I have AB, it's a diameter, equal twice the radius, because the radius, as we said, is the distance from any point on the circle to the center. It's 1. Let's move another 1 from the center to any point on the circle, 2. So I have the diameter equal twice the radius. After that, you have the chord. What is the chord? The chord, it's a line segment drawn, as we said, it's a line segment whose endpoints lie on the circle. You can choose any line segment and draw its endpoints on the circle, join between them, you will have a chord. So I have CD is a chord. As we said in the chord, we said that the chord is a line segment joining between any 2 points on the circle. But if you have this chord passing through the center, it will be changed into a diameter. So we can say that the diameter is a chord passing through the center. After that, you have a very important remark. It says that the longest chord is the diameter. So you have many chords in the circle, but the longest one of them is the diameter because it passes through the center and the diameter is the longest chord in the circle. So you have studied the radius, the diameter, and the chord. After that, you will have some live application. Let's see, it's a girl measuring the thickness or the whole of the tree or the width of the tree. You can estimate the age of a tree by measuring the circumference of the tree. For many kinds of trees, each 2 centimeters represents 1 year of growth. How? Any tree, this tree having the shape of a circle. So, we can know the age of the tree by measuring the circumference of the circle for many trees, and each 2 centimeters represent 1 year. So, if you have the circumference is 100 like this, so the age of this tree is 50 years. So, some live applications of studying the circle is to know the age of the tree. After that, have you asked yourself how can we measure the distance the car moves? Okay, let's see. This is the wheel of a car. We can see that an odometer is an instrument used to measure the distance a vehicle travels by counting the number of wheels of revolutions. So we can see that when this vehicle moves, so it moves with a length like the circumference of this circle. So if you counted how many circumference have you cut, you will know the distance that the car moves. So you can know the distance of the car by knowing the number of turns. So these are some live applications for studying the circle. Now, you will have the circumference and the area of a circle. How can we know the circumference? Well, to know the age of the tree and to know the distance that the car moves, you must know the circumference. How can we count the circumference? Or how can we calculate the circumference? The circumference of a circle is represented by C equals 2 by R. So what's pi? The pi is an approximated value and it's constant. And R is the radius of the circle. What's pi? We can see that if you count the circumference of any circle and you will divide this circumference by twice the radius, you will have a fixed value. This value is pi. So for many circles or for any circle, if you have the circumference divided by twice the radius, you will get pi. So we can say that pi is an approximated value and it's constant. So the circumference equal twice pi times r. After that, what is the area? As we studied before, we have the area of the circle is pi times r squared. So if you have the radius, if you have pi and you can see that pi is 22/7 or 3.14. You can count the area and you can count the circumference of any circle. So we have studied the basic definitions or the basic parts of the circle. Number one, the center of the circle, and we said that the center is a fixed point inside the circle that have equal distance from any point on the circle. After that, we have studied the radius, and we said that the radius is a line segment drawn from the center of the circle to any point on the circle. After that, we have studied the diameter, and we said that the diameter is a line segment passing through the center, joining between 2 points on the circle. So, to have a diameter, you must pass through the center of the circle. After that, we have studied the chord, and we said that the chord it's a line segment joining between any 2 points on the circle. And if you have this chord passing through the center, it will be changing into a diameter. And we said that the longest chord in the circle is the diameter, and the longest chord in the circle is the diameter, and the diameter is the chord passing through the center of the circle. And we said that the circumference is equal to pi r, and the area equals pi r squared. Now we will move to another point. Number 1, drill. Find the value of x and y in each of the following. Number 1, if you have a circle like this, as we studied in the revision, we have the isosceles triangle, and we can say that the 2 angles of the base in the isosceles triangle are equal in measure. Let's use this basic concept in this figure. I have triangle AMB. This triangle is isosceles triangle according to the 2 radii that are in the circle. As we said, the radii of any circle are equal in length. So we can say that MB equals to MA. From MB equals to MA, you will have the 2 angles of the base are equal, the 2 angles of the base are equal in measure. So we can say that if measure of angle B equals 30 degrees, you will have measure of angle A will be 30 degrees also. To get the value of x, x will be 180 minus 30 times 2, and this will be equal to 120 degrees. So the value of x is 120 degrees. Let's move to another example or exercise. If you have a figure like this, I have M is a circle, and you have given MB equals to DA, they are equal in length. You have triangle A and C, and you want to get the value of x and the value of y. Let's start from the part that you know. I have triangle ADM, it's an isosceles triangle. This isosceles triangle having 2 angles of the base, angle DMB and angle A. They will have equal measures, so we can say that measure of angle A will be 25 degrees. From having measure of angle A equal to 25, you can say that measure of angle x, or we can say that x, it's an exterior angle for the triangle ADM. So this exterior angle equals the sum of measures of interior angles except the adjacent. So we can say that x equals 25 plus 25 equals 50 degrees. You can get the value of x by another way. You can get the value of measure of angle MDA. It's equal to 180 minus 25 times 2, and this will be 130 degrees. And you can see that x, it's a supplementary angle for this angle. So the measure of angle x will be 180 minus 130, and this will lead you to get it 50 degrees as we said. So I have this angle as 50 degrees. After that, triangle MDC. It's also a isosceles triangle. Why? You have MD is a radius and MC is a radius, and we said that the radii in the same circle are equal in length. So we can say that this side is equal to this side. This is 50. You can say that measure of angle C also is 50 because the angles of the base in the isosceles triangle are equal in measure. You can get the value of y like this. Y equals 180 minus 50 times 2. This will be 80 degrees. After that, you have the third example. Let's erase what we have written. In this figure, I have triangle ABM and triangle ACM. These two triangles having measure of angle A and B equals to measure of angle A and C. you want to get the value of each of x and y. If you have two triangles, start to get one of the cases of congruency between the two triangles. I have triangle A and B and triangle A and C. Let's search for some cases of the congruency between them. I have MB equals to MC equals to MA because all of them are radial. So we can say that MB equals to MC. And we can see that AM is a common side between the two triangles. Also we have this red angle equal to the red one. So we can see that triangle AMB congruent to triangle AMC. By the case, side, angle, side. You must make sure that the angle included between the two sides. I have AM as common side, MB equals to MC, and measure of angle AMC equal measure of angle AMB. What will you deduce from the congruency? I said that triangle AMB congruent to triangle AMC. We will deduce that AB equals AC equals 10 centimeter. And this is the first deduction. So I have AC equals 10 centimeter. So we can see that X equals 10 centimeters. So this is the first reply. After that, I want to get the value of M, of Y. I have measure of angle MAB equals 25. We can see that. Also measure of angle CAM or MAC equals 25. Measure of angle MAC equals 25 also. Why? Because the two triangles are congruent. So we can say that it's 25. I have AM equals 2MC because they are two radii in the circle. So we can say that this is 25 and Y will be 25 also because Y will be 25 degrees because triangle AMC is isosceles triangle. We have finished some examples about the circle and the basic definitions of the circle. Let's move to another point. Okay, let's erase what we have written. If you revise what we have studied, you will find that we said that the axis of symmetry of any line segment, we said that it's the perpendicular bisector of the line segment. And we said that the axis of symmetry of any figure divides this figure into two halves that are congruent. So we can say that if you divide a man from this part, you will have two symmetric parts. One leg and one leg, one hand and one hand, one eye and one eye. So you will have two symmetric parts. So I have this figure, it's a circle. If you have straight lines like this, all of them are passing through the center of the circle. Let's have this straight line. If you look at this straight line only, you will find that this straight line will divide the circle into two congruent parts. Like when, if you fold them, you will find that they are congruent. If you cut the pizza, do you know the pizza? Okay, if you bring one of them and cut it like this, you will have two symmetric parts. So I have the straight line that divides the circle into two congruent parts. We name it by the axis of symmetry for the circle. I have an axis of symmetry, axis of symmetry, axis of symmetry, axis of symmetry. Okay, you can't draw any extra axis of symmetry. Okay, you can't draw because there is an infinite number of axes of symmetry for the circle. The definition says that the axis of symmetry of a circle divides it into two semicircles. What is a semicircle? It's half a circle. Like your protractor, it's a semicircle. Okay, after that, any circle has an infinite number of axes of symmetry. Okay, let's ask you a question. How many axes of symmetry are there in the semicircle? We said that you have an infinite number of axes of symmetry for the circle, but you can say that for the semicircle you will have only one axis of symmetry, because the semicircle is a figure like this. So how can we divide this part into two congruent parts like this? Only like this. You will have 2 quarters. So this half will be divided into 2 quarters. So we can say that the semicircle has only one axis of symmetry, and the circle has an infinite number of axes of symmetry. You have some important corollaries about the circle. Corollary number 1. The straight line passing through the center of the circle and the midpoint of any chord of it is perpendicular to this chord. Let's see the figure. I have a circle M. I have a straight line and I have a chord AB. This chord AB is divided into 2 parts by the point C because it's a midpoint. If you have a straight line passing through the center of the circle and the midpoint of the chord AB, what will you have? You will have that this straight line will be perpendicular to the base according to the corollary. The straight line passing through the center of the circle and the midpoint of any chord of it is perpendicular. So if you have a straight line passing through the midpoint and the center, what will you deduce? You will deduce that this straight line will be perpendicular to this chord. If AB is a chord of a circle M and C is the midpoint of AB, then MC will be perpendicular to AB. This is the first corollary. So you have pass, bisect, the result will be perpendicular. After that, corollary number 2. The straight line passing through the center of the circle perpendicular to any chord in it bisects this chord. So what is the given here and what is the deduced? I have a straight line passing through the center, so it passes through M, and perpendicular to any chord in it. So it's perpendicular to the chord. What will you deduce? Well, divide this chord into 2 equal parts. So it bisects this chord. So I have the given is that AB is a chord of the circle M, and MC perpendicular to AB is a given. What will you deduce? You will deduce that C is the midpoint of AB. After that, you have corollary number 3. Sorry, it's corollary number 3. The perpendicular bisector to any chord of a circle passes through the center of the circle. Perpendicular and bisector passes through the center of the circle. So if AB is a chord of circle M, and C is the midpoint of AB, and the straight line L is perpendicular to AB and C, then M belongs to the straight line L. So I have perpendicular bisector, so it passes through the center. So I have 3 words: pass, bisect, perpendicular. If you have 2 of them, you will deduce the third. Perpendicular and pass, you will deduce that it's bisect. Bisect and perpendicular, pass. Pass and perpendicular, bisect. We can name straight line L by axis of symmetry because it's perpendicular, bisector, and passing through the center of the circle. Okay, now we will move to exercises on these corollaries. Finish.